Hello guys, welcome to our channel Niperian Solutions. So today we are going to discuss about the questions regarding the pharmaceutical analysis for the FDA Maharashtra exam. So the date has been declared, that is the 30 and the 31 December of the 2024. So here we are discussing the previous year questions from the 2017 for the same exam, right? That is the chemical analyst. So we will discuss one by one that previous year questions. So let's start with first one. So what is the question here? That is the electromagnetic radiation is characterized by, right? So the electromagnetic radiations are characterized by the, your options are amplitude, periodicity, wavelength and wave number of the frequency and all of the above. So here from all the options, so which one is the relevant to us? So that is nothing but the wavelength and the wave number of the frequency, right? So that is the answer. So we will discuss how the wavelength, wave number and the frequency are correlated, right? So here example, the lambda is nothing but your wavelength and that mu bar, that is your wave number, right? So suppose here 2.5 micron is your lambda, so that is 2.5 into 10 to the power minus 4 centimeter, right? Because micron is nothing but the 10 to the power minus 4 centimeter. So here lambda is 2.5 into 10 to the power minus 4 centimeter. So we will calculate the wave number. What is the wave number for the given lambda? So that is formula is given, that is the 1 divided by lambda. So 1 divided by that 2.5 into 10 to the power minus 4 centimeter, and we will get the 4000 centimeter inverse. So that is also very important. The unit for the wave number is centimeter inverse, and generally the wave number is the basic unit that we use in our IR spectroscopy, right? Infrared spectroscopy, right? So lambda and wave number, these are the reciprocal of the each other, right? What about the frequency? Frequency is inversely proportional to the wavelength. Then here is a small table that we are discussing, right here. Okay, so what is that? So here 0.8, 2.5, 15 and 200 micron. So that is the wavelength. So means what we can say, right? So what we can say here, as wavelength increases, the wave number decreases. So here you can see guys, the wave number start with the 12,500, but as wavelength increases from 0.8 to 200, here wave number decreases from 12,500 to the 50 centimeter inverse, right? Okay. So the next question, the retention factor for a particular solute depends upon, right? So the option A, stationary phase, mobile phase, both 1 and 2, none of the above, right? So what is the answer here? Answer is the both 1 and 2, right? Because the retention factor is depend on the stationary phase as well as the mobile phase also, right? So here two types of chromatography, one is the normal phase and the reverse phase. So in normal phase chromatography, stationary phase is used as a polar one and the mobile phase is non-polar. Means what happen in the normal phase chromatography, the non-polar compounds elute first, right? And in reverse phase chromatography, stationary phase is non-polar and the mobile phase is polar. Means in reverse phase chromatography, the polar compounds elute first. So that is the elution criteria, right? So next question, TLC is a separation technique based on, right? So what are the options here? Solubility, adsorption, partition and fractional distillation, right? So here our answer is, right, what it is, that is nothing but the adsorption. So TLC is the separation mainly based on, so what is the principle of TLC? That is nothing but the adsorption, right? The next one, how many signals will diethyl ether give in PMR spectra? So what is PMR? That is the proton NMR, right? So options are 1, 2, 3 and 4, right? So what is the answer here? Answer is 2, right? There are the two NMR spectra or the proton NMR spectra showed by the diethyl ether. So we will see how it looks like. So that is the structure of diethyl ether, right? So how many signals are there? So there are the two signals, right? But how? Right. So here are the two sets of proton. This is one, right? So these two CH3 molecules are the magnetically and chemically equivalent. So these two CH3 give only one peak, right? And here in between there is a CH2 here, this one, right? So these CH2, these are also chemically and magnetically equivalent. So these give only one peak, means this CH3 has one and CH2 that is the second peak. Similarly here also that is the 1 and that is the 2. So means this 2 CH3 and 2 CH2 gives only one peak in the proton NMR spectra, right? Okay. So next one, when a molecule absorbs UV or visible light of a frequency mu or wavelength lambda, an electron undergoes a transition from a lower to higher level, right? The energy difference. So generally the very basic question, they just asking, so what is the formula for the delta E, right? Or the change in the energy or the difference in the energy. So what is the formula here? So the options are delta E is equal to H mu, delta E is equal to HCV, delta E is equal to 1 by 2 mu square, and delta E is equal to C upon lambda, right? So as we all know, so what is the formula or what is the what is the energy delta E? So delta E is nothing but the delta E is equal to H mu, right? So we will see how it works. Okay, here, so E is equal to H mu, right? But what is the mu? Mu is nothing but the C upon lambda. So E is equal to Hc upon lambda, and here H is nothing but the Planck's constant. So that value is also very important, 6.626 into 10 to the power minus 27 or second. You have to remember that is also very important for the exam point of view, right? So the next question is, the data shift is the position of an absorption peak relative to that of the reference compound, right? That is very simple question, like red, blue, chemical, red and blue. So these are the four options. So generally what happen, that question is from the NMR, right? And according to the NMR, so from the option, here answer is only the chemical shift, right? What is the answer? Chemical shift. That is nothing but the delta. So what is in NMR? Delta is nothing but the used for the chemical shift. Okay, so here are the two options, red and blue shift. So what are those? That is actually not related to the, what we can say, the NMR. Actually that is related to the UV spectroscopy. So blue shift and red shift. So what is the blue shift? Blue shift is nothing but that the shift which is towards the longer wavelength, right? And what is the red shift? That is the shift towards the shorter wavelength. So these three are very important, but the chemical shift is not related to the UV, that is related to the NMR spectroscopy, right? For the next one, in dash NMR spectral determination, mostly carbon tetrachloride and deuterochloroform are used as solvent for dissolving the samples. So again this question is from the NMR, right? So the options are proton, carbon 13, nitrogen 15 and fluorine 19, right? So what is the option here? That is also very basic question, that CCl4, carbon tetrachloride and deuterium chloroform, CDCl3, right? So where we are using this in the proton NMR, right? I hope these things are very clear to you guys, right? The next one, in dash analysis, gas chromatography separates the component of a mixture while the mass spectrometer gives the structural information via fragmentation. That is also a very simple question, means they are combining the two type of spectroscopy, right? Like one is the chromatography and another one is the spectroscopy. Means gas chromatography is there, means obviously that is the GCMS. What is the answer here? GCMS, right? Option is here the GCMS. Okay, so the next question, the loss of an alkene fragment by a cyclic rearrangement of a carbonyl compound with dash dash hydrogen is termed as McLafty rearrangement. The simple question from the McLafty rearrangement, so that we know in McLafty rearrangement which hydrogen is important. Yes, that is nothing but the gamma hydrogen. So any compound like carbonyl compounds or any electron deficient compounds where the gamma hydrogen is present in that, so then and then only McLafty rearrangement is possible. So that is the very basic requirement for the McLafty rearrangement. So that is the gamma hydrogen. Okay, so the next question, the base ion peak at M by Z 43 in the mass spectrum is due to the loss of, right? So what is the here question is that, so as like 43, so M by Z ratio 43, methoxy group, carbonyl group, methyl group and acetyl group. So what is the answer here? That is the acetyl group, right? How it is just showing the CH3 C double bond O. So these ion are the acetyl group and the molecular weight of this one is the 43 CH3CO, right? So that's why the answer is acetyl group. The next question, which proton readily exchanges with deuterium? Aldehydic, hydrocarbon, aromatic ring and hydroxyl proton. So what is the option here? That is nothing but our hydroxyl proton, right? So these are very readily exchanges with the deuterium. Okay, so the next one, dash dash is used as a reference standard in NMR spectroscopy. The options are tetramethylsilane, trimethylsilane, dimethyl and dimethyl sulfoxide. So what we are using, that is the TMS, right? That is the tetramethylsilane, right? So what is the structure of the tetramethylsilane? So the silica is just centered, CH3, again CH3, CH3 and again CH3, right? So here that all the chemicals, like say all the protons are chemically and magnetically equivalent, so it is showing the delta value 0. So that's why it is used as a reference standard in the NMR spectroscopy, right? So what is the answer over here? That is the tetramethylsilane, right? So the next question, how many signals will be obtained in the proton NMR spectra of propane to oil, right? So before going to the answer, we have to know the structure of the propane to oil, or what we can say, that is the isopropyl alcohol, right? Or 2-propanol, one and the same thing, guys. So what is the answer here, right? The options are 1, 2, 3 and 4, right? So propane to oil, so what is the answer? So your answer is 3. So how? Okay, let's discuss how. So this is the isopropyl alcohol or propane 2L or 2-propanol, that one and the same thing. So here are the different sets of proton, right? Okay, different sets of proton. So this CH3 and this CH3, that is the one set of proton, right? Again this OH, that is the another set, and the last one this CH. So these set of proton giving the signal in the 2-propanol, right? Means these two CH3 give one signal, right? This one and this one give one signal, this one is give a separate signal, and this CH is also giving a separate signal. Means this 1, 2 and 3, here are the 3 signals are possible in the 2-propanol, right? The next question, in NMR spectroscopy, in every sample a small amount of dash dash is added as a reference, right? So what is the option here? That is the tetramethylsilane. So previously also we have seen the same question. right? Tetramethylserine as a reference standard we are using. Next, the peak of highest intensity in a mass spectra. So that is also a very basic question. So what is that? The highest intensity peak, that is nothing but the base peak. What it is? Base peak in the mass spectrometry. So again, in NMR spectroscopy, the tau scale value is. So what is the tau scale value? Here options are 10 minus sigma, 10 minus beta, 10 minus delta and 10 minus gamma, right? So there is only one symbol that is very relevant to the NMR spectroscopy, and that is nothing but our delta, because alpha, beta, gamma, these are not used in the NMR spectroscopy. So only delta is nothing but the chemical shift. So chemical shift is also explained in the two different forms, that is the delta and the tau. So they are just using the like formula for the tau, that is the 10 minus delta. For proton NMR, the delta value is like 0 to 12 ppm, and for the carbon NMR, right, or the C13 NMR, the delta value start from the 0 to 200 ppm. That is the difference here. The next one, the which of the following is a Henderson-Hasselbalch equation, right? So what is the option here? So you can see that all the options. So what is the right answer over here? Yes, so that is the option number 4, right? So generally salt upon acid, right, for the Henderson-Hasselbalch equation for the measurement of pH. In radioimmunoassay, the commonly used gamma emitter radioisotope label with a half-life of about 60 days is. So what is the answer here? That is iodine 125, right? What is the answer? Iodine 125. Iodine 131, where we are using this one? So this one we are using in the as an anti-thyroid drug, or for the destruction of that specifically what we can say, that gland and all in the thyroids, right? Next one, the Km of an enzyme is, right, 1/2 of Vmax, a dissociation constant, the substrate concentration at half of the maximal velocity, the substrate concentration at the maximal velocity, right? So what is the answer here? That is nothing but the, yes, the substrate concentration at half the maximal velocity, right? So here, so these are the different like forms, right? So that is the equation is nothing but the Michaelis-Menten equation, right? So here Vmax into S divided by Km plus S. So that is nothing but the velocity of a reaction. So Vmax is the maximum velocity, right? Then what is the S? S is the concentration of a substrate, and Km is the Michaelis constant. So sometimes S is also replaced by the C, because that is nothing but the concentration, means the formula is like Vmax into C divided by Km plus C. So it is totally dependent, right? Okay. So the next one, the degree of unsaturation in a lipid is measured by, right? So the saponification number, iodine number, acid number, Richard-Michel number. So here we know the answer. So that is the iodine number. Okay. Next, which of the following is required for the DNA synthesis but not for RNA synthesis, right? So what is the answer here? Nucleotide, sugar, polymerase and primer, right? So what is the answer over here? So that is nothing but our primer. Okay, because these all the three, nucleotide, sugar, polymerase, these are also included in the RNA synthesis, right? And the last question from today's series, that is, which of the following separation technique depend on the molecular size of the protein? So as we know, so this is also one chromatography technique, and actually it is based on the molecular size of the protein. So what is the name of that chromatography? That is the size exclusion chromatography, right? right? So what are the options here? Isoelectric focusing, gel filtration chromatography, ion exchange chromatography, and affinity chromatography, right? Our answer is size exclusion chromatography. Okay, so here gel filtration chromatography is there because size exclusion chromatography, SEC, also known as the gel filtration chromatography, right? Okay, so these are the questions from the previous year that they have asked. So accordingly we will prepare for the FDA Maharashtra chemical analyst exam. So these are the some PYQs. So again in the next video we will discuss about the some important topics. Okay, so guys, please subscribe the channel, share with your friends. Okay, thank you.